Hello guys, hope you have been having a very lovely day. In this video, I want to tell you how to convert a binary number into an octal number, into a hexadecimal number, and also an octal into binary, hexa, and a hexa into binary and octal numbers. So, first of all, I would like to start by telling you about the radix of these systems. Binary is your base 2 system, octal is your base 8 system, and hexadecimal is your base 16 system. So before we actually know how to make these conversions, it is important to know what digits are actually allowed in these systems. So, as the radix suggests, 2. For binary numbers, the digits allowed are only 2. Starts with 0 and ends with 1. So 0 and 1 are the only digits you can use in a binary number. And octal, the radix is 8. So as the name suggests, only 8 digits are allowed in octal. So you have 0, 1, 2, 3, 4, 5, 6, and 7. So 0 to 7 you have 8 digits. So 0 to 7 are the only things that are allowed in an octal system. And hexadecimal is your base 16. So as the name suggests, you are allowed 16 digits. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're not gonna write 10 because see, you're being faced with one complexity here. In a decimal number, you're allowed 10 digits, so you have 0 to 9. In a hexadecimal number, you have 0 to 9, and after that, if you're using 1 0, you're repeating the past digits. There are no 16 digits in them, then that is a decimal system. So in a hexadecimal system, there is a special case where 9 U is followed by A. A is the equivalent of 10 in decimal system. And B is 11, C is 12, D is 13, E, F. So A, B, C, D, E, F. 10, 11, 12, 13, and 14. So 0 to 14, that makes it 16 digits. So you don't write it as 10, you write it as A, 11 is B, 12 is C, and so on till F. So F is 14. So, now, once you have all these, now I believe you're clear with what digits you can actually use in a hexa and octal and binary systems. So now let us see the very simple conversions which we use. And before that, let us learn about the equivalent of binary or octal or hexa in the decimals. One more table. So now, as you can see, I have written 0, 1, 2, and I've left a space and written 7, and I've left a space and written 10. Now, let us see what these numbers can mean in binary, octal, and hexadecimal numbers. So now, 0 in binary is 0 itself. And 1 in binary is 001. Let me take 4-digited binary numbers. 4 or 3, it's not gonna change the meaning. It's not gonna change the value. And 2 in binary is... And I'm leaving a blank and I'm writing 7 again. And 7 is 0111. And 10 is 1010. Now, as we all know that in octal, the number representation is 0 to 7. It starts with 0 and ends with 7. You don't have any further numbers. So, the value of, up to 7 digits, up to the value 7, it can indicate, but beyond 7, if there is, say for example, 8, it can do it. Let me show you that. So 0 in octal is going to be 0, 1 in octal is going to be 1, 2 in octal is going to be 2, 7 is going to be 7, but if I say 8, 8 in octal is going to be 1, and the next one, you have the 0, it's going to be 10. So let me also write the binary equivalent of 8. So now things are going to be a bit clear. So 10 in octal is going to be, you have a 10, then 9 is going to be 11, and so 10 is going to be 12. So 10 in octal is going to be 12. And in hexadecimal, 0 is going to be 0, 1 is going to be 1, 2 is going to be 2, 7 is going to be 7, 8 is going to be 8. But 10, you don't have a 10 in a hexadecimal number. If you're using 10, and if you're saying that a 10 in decimal is 10 in hexa, it's no longer hexa. It's as good as the decimal number. So you're going to write A for 10. Now that we know how long you can represent something, let us go to the conversions from binary to octal and hexadecimal. First, let me start with binary to octal, because this is going to be very, very simple. All of these are very simple, no doubt. So let me start with a small example of, tell me a binary number, any binary number that comes to your mind. Say 1001011, anything that comes to your mind, really anything. So now, the first step in converting a binary number to octal number is starting with the rightmost, that is with the least significant digit, divide this into three parts. So that each part contains 3 digits. So you have from the right, starting from the right, count 3 digits, pause, count 3 digits, pause, count 3 more, pause, so on. In our case, we have 3 in one block, 3 in the second block. In the last block, I have only 1, which means I can add a 0 and a 0. It's not going to change the meaning. So even if you're not adding there, no worries, because your answer is not going to be different. So now, the next step in converting is write down from the rightmost, write down the equivalents, just write down the decimal equivalents of those binary numbers. I know that you know how to convert decimal to binary. If not, I'll be soon making a video on that. So 011 is 3, 001 is 1, and the next one is also 001, so that is also 1. So our required octal number is 113 base 8. So as you've seen, so that is how you convert an octal number. That is how you convert a binary number into an octal number. Now let us see how you convert an octal number into a binary number. Just do the reverse. Say you have an octal number 534. This is my octal number. So the first thing I'm gonna do is write down the 3-digit equivalent. Listen to this. The 3-digit equivalent binary numbers. So 4 it's 100, 3 it's 011, and 5 it's 101. So this whole thing is the binary equivalent of the above octal number. Say for example, you might ask me, now if I'm taking a 4, say you consider the 3, 534, consider the 3. Actually, if you just write down 1 in binary, the meaning is gonna be 3. But when you're converting an octal into binary, you should not miss this 0. You have to write the 3-digit equivalent of the octal of that particular digit into binary. So in this way you can convert an octal into binary. Now this is really simple. I'll show you another example. I have 6, 3, there can be a 9. 9 is not in the octal thing. 6, 3, 4, am I repeating digits? So this is my octal number 63752. I need to convert it into binary. So the first thing what I'm gonna do is write down 2. What is the 3-bit binary equivalent of 2? It is 0, 1, 0. The 5's equivalent is 1, 0, 1. And for 7 it's 1, 1 and 1. For 3 it's 0, 1, 1, and for 6 it's 1, 1, 0. So all this, the whole thing is your binary equivalent of the given octal number. These 3, 3, 3, 3. That is how you convert an octal into binary and binary into an octal. When you're given a binary number, starting from the right, count 3 digits, give a pause, count 3 digits, give a pause, and write down the equivalent number of those 3 digits down. And that is just your octal number, 3 digits, 3 bits. Remember that. So if you have understood how to convert an octal into binary and binary into octal, you have already understood the hexa and binary. Hexa and binary is as simple as octal and binary. So for octal, you have considered 3 bits. For hexa, you will be considering 4 bits. That is the only difference between the octal and hexadecimal conversions from binary and the opposite. So just for the sake of an example, let me take the you want me to start with a binary or okay, I'll start with a binary number. So I have the binary number 100110111. So as I've already told you, you have to take 4 digits. So starting from the right, take 4 digits, cut it, take another 4 digits, that's it. And this one and another 4 digits. So I can in fact put 0001. Even if you don't add 000, it's not gonna do any change to it. The value is gonna be same. So now write down the equivalence of those 4 bits. So 0111. So 0111 is 7 in hexadecimal, and 0011 is 3 in hexadecimal, and 0001 is 1 in hexadecimal. So this binary number is 137 base 16. So let me take another example to make things more clear so that you can actually get the grip of some alphabetical numbers too. So 1101101111. So now, starting from the right, I'm gonna take 4 digits. 4 digits, another 4 digits, and another 4 digits. I don't have 4 digits of my leftmost block, so I can add a 0 if I want. That is only to avoid confusion. If you are actually fine with it, you can go on and proceed without adding the 0. That's even better if you can do it. So now I'm gonna write down the equivalence. So what is 1111 in hexadecimal? Is 14. Yes. So okay. So that is 111 is 8 plus 4 plus 2 plus 1, that is 15, and 15 in hexadecimal is F. So I'm going to write down F, and the next thing is 0110, and 0110 is 6. That is 4 plus 2 is 6. Yes, is 6. And the leftmost is 0111 is 7. So my hexadecimal number is 76F. So this is my required hexadecimal number, which I've obtained from the given binary number. Now, as a final example, let us see the conversion of a hexadecimal number into a binary number. So let me take A3FB. So each digit, write down the 4-bit equivalent binary number. So B is 11. So what is 11 is, I'll do it for you. So 8 plus 2 is 10, and 0 and 11. So 1101. That is 8 plus 4. Sorry. That is slight mistake. It's 8 plus 2 plus 1. That's better. So 1011 is B. That is 8 plus 2 plus 1. That is 11. Yes. So B is 1011. Remember, you have to write the 4-bit equivalent if you're writing into hexadecimal. If it was octal, you would have written the 3-bit equivalent. Remember, since 7 is the maximum thing you can obtain in octal, writing a 4-bit would be absurd, because that's not writing a 4. For example, you have B, you can't put it in 3 bits. It's really absurd. So you need to understand there itself that you can't write B in octal. Sometimes in questions they do give B and they might not give you what base it is. Then you really shouldn't get confused. You should understand that it is a hexadecimal number. So now writing F, and F is 1111, 4-bit equivalent, remember? And the 3 is 0011. See, but for 3, even if I've written 11, it would have been correct. But I need to write the 4-bit equivalent because I'm finding out the hexadecimal number. So I have to write 4 bits without fail. That too, when the digit is not the leftmost, you have to write 4 bits. If you don't write those 2 zeros thinking that they don't add a value, you're terribly wrong. The answer is also wrong. So now writing for A. A is 10, so 1010. Yes, that would do. So this is your required binary equivalent of the given hexadecimal number. So the above is base 16. So hope you have found this video very informative and hope it was helpful. If you have any queries, just please comment below. Thank you and have a lovely day.